All right. So we're going to talk about our last theme for this unit, which is coming back to ocean acidification. And now I want to focus on how can we shift ocean acidification? So how can we tie in this idea of equilibrium and disturbing equilibrium and use that to our advantage when it comes to decreasing the amount of acid that's entering our ocean so that our pH doesn't continue to decrease. So, what have we learned so far? Let's summarize. First, ocean acidification is a change in the chemistry of our oceans that happens because there's increased levels of anthropogenic carbon dioxide in our atmosphere. We defined anthropogenic. That means caused by or created by humans. It doesn't refer to any one thing in particular, just anything made by or an effect from what we humans do in our activities. So a lot of things change when we increase CO2. The pH of the ocean changes, the carbonate ion concentration changes, and then we can see the cascading changes to the ecosystem and the impacts to humans and our industries that revolve around the ocean. There are some things I want you to keep in mind, though, and that is that the entire ocean is not going to die because of this. In fact, the ocean's not going to even actually become acidic. Despite the name, it's not going to decrease below a pH of 7. Now, normally the ocean actually should be at a pH of about 8 point something. Right now, it's in the 7 point somethings, and it can continue dropping, but we don't expect, or we don't think we'll ever see anything below 7. Um, Lastly, most living organisms are not going to have their shells dissolved. We're talking about an increase in the dissolving or the weakening of them, but not every living organism is going to have its shell dissolved. We do need to remember that oceans and humans are interconnected and dependent on each other. All right, what I'd like you to do now is pause the video and switch over to the link that I have in Google Classroom and watch this 1 minute and 40-second video that I have for you. So go ahead and pause now. All right, now that you've seen that video, I want to talk about what can we do? Well, we can deal with the cause, we can make short-term fixes, and we can find out more information. What I want us to focus on is how we can deal with the cause. How can we decrease the concentration of anthropogenic carbon dioxide so that we shift the reaction to the left? Or in other words, favor the reactants so we're not making that product that is our acid. All right, on the Google Doc that I've posted, I would like you to take a moment and in the two charts, I want you to brainstorm the following things. In the left hand of the chart, I would like you to brainstorm what specific actions could be taken to reduce carbon dioxide emissions. So what can be done that will decrease the amount of CO2 being created? Secondly, in the right-hand column, I then want you to think of what would prevent someone from carrying out the actions that you've suggested. What might be a barrier to that action? Again, please pause the video and take a moment to brainstorm those. I'd like you to aim for coming up with 5 actions. All right, so you've taken some time to think about some actions. Now I want you to look at what you have and decide what would be the most effective. Now I'm going to refer to this as conserving energy. In the United States, the majority of our energy comes from the burning of a fuel that releases carbon dioxide. So, as we talk about carbon dioxide, we can also talk about conserving energy, and the two go hand in hand. So, take a look what you have and decide what would be the most effective of your options. What would have the biggest impact or the greatest reduction in CO2? All right, we're going to pause or not pause. We're going to skip this because we're not together as a class. So what I'd like to talk about now is where is all of our energy use? So we're going to start looking and comparing at what you thought about and what the data says. So if we look at the typical household in the United States, at their total energy use, 57% of the energy is used to do things within the home, And 43% of the energy that each of us use is to transport ourselves around. What kind of transport are we doing? Well, that 43% can be broken up as follows. 91% of all of our transportation energy is in the form of driving our cars and our trucks, our personal vehicles. About 7% comes from traveling by plane, probably to go on vacations, or some people travel for business. And about 2% is for mass transit. So taking the bus, taking the train, that's going to use energy as well. So most of our energy use comes from the personal driving of cars and trucks. Where is this other energy? If we look at the home, the biggest use of energy is to heat or cool your home. After that, it's to power your electronics like appliances in your kitchen, motors, TVs, cell phones, computers, then to heat your water, to light your home, to refrigerate and freeze your food, to wash and dry your clothes, to cook your food, and lastly, to clean your dishes. So, based on this data, what are the most effective steps we can take? Let's look at them. First and most effective thing you can do in terms of reducing that percentage of energy is to buy a more fuel efficient vehicle, actually limiting the output of carbon dioxide. After that, what you can do, you can adjust your driving habits. So if you can't get a more efficient vehicle, you can use your current vehicle more efficiently. So you're driving less. You can insulate the attic of your home. Now in the summer, it stays cooler. In the winter, it stays warmer, so you don't have to use as much heating. You could also install a more efficient heating or cooling unit, so it uses less energy when it's heating or cooling your home. You can maintain your vehicle. A maintained vehicle is more efficient and uses less energy and therefore less CO2. You can carpool to remove a vehicle off the road. You can switch out your light bulbs to LED light bulbs. These light bulbs, if you run them for the same amount of time as what we call an incandescent bulb, use 85, use much less energy than the same incandescent light bulb. So they're more efficient in getting the same job done. You can replace windows with more efficient ones so that they let less heat into your home so it stays cooler. You can use your heating and air conditioning less. You can wash your clothes in cold water instead of hot water. You could get a more efficient washing machine so every wash you do uses less energy. And lastly, when it's warm out, which is more than 5 months of the year here in California, you could dry your clothes on a line instead of using the dryer. So all of these were ranked in terms of their efficacy. What I would like you to do now is take a look at questions 8, 9, and 10 on your worksheet. Reflect on this list and answer those questions. Once you've done that, the last part of the handout can be done on your own with the provided link. Thanks for tuning in. Stop recording there.